Hi there! This video is a review of how to solve one-step equations using properties of equality. So we're going to review each of the properties and do examples of each. As you can hear, my dog Toby is very excited about this lesson. Alright, so the first property is the addition property of equality, which says if you add something to one side of an equation, you have to add that same thing to the other side. It looks like this. If A equals B, then A plus C equals B plus C. Here is an example of when we would use this. Let's say that x minus 1.8 equals 7.4. So we would use the property of equality for addition so that we could get the x by itself. So since we are subtracting 1.8, I could add 1.8 to both sides. So I'm going to draw a line where the equal sign is. Add 1.8 to both sides of that equal sign. The x is still there and nothing has happened to it, so I drop the x down here. Opposites, when you add opposites, you get 0. So minus 1.8 plus 1.8 is 0. Anything plus 0 is itself, so we say that those cancel. So we don't have anything to put down here because it's 0. And on the other side, we are going to add 7.4 plus 1.8. And we get 12 when we do 4 plus 8. The decimal point drops down. We add the 1 up there, carry the 1, so we get 9.2. So we have solved the equation using the addition property of equality, and we now know that x equals 9.2. So that's my example. What I would like for you to do in your notebooks is do your own example. Let's do x minus 6.3 equals 1.7. Solve that in your notebooks and then have a teacher check to see if you are right after you compare it with a friend. Please pause the video until that problem is done and then resume it to continue on with these notes. The next property to discuss is the subtraction property of equality, which says if you subtract something from one side of an equation, you have to subtract it from the other side in order for it to still be an equation. It looks like this. If A equals B, then A minus C equals B minus C. So let's do an example where we would use this property. Let's say that we have x plus 4/9 is equal to 7/8. So in order to get the x by itself, I would have to take away or subtract 4/9. So let's draw a line where the equal sign is, and we are going to subtract 4/9 from both sides. And that is using the subtraction property of equality since I did it to both sides. Now let's take a quick review on how to subtract fractions. We have to first get the fractions to have the same denominator. So this x that you see here remains there, so we're going to drop the x down. The positive 4/9, which is the plus 4/9, and the minus 4/9, when you add opposites you get 0, so that goes away because it's x plus 0, which is just x. And now let's work on 7/8 minus 4/9. We have to get a common denominator. Remember, the denominator is the number on the bottom. 8 and 9 have a common denominator of 72. So let's change those so that they have denominators of 72. Now, how do we change 8? What do we multiply 8 by to get 72? We multiply it by 9. So if I multiply the bottom of a fraction by 9, I have to multiply the top of the fraction by 9. And 7 times 9 is 63. On the bottom, 4/9, in order to get 9 to be a 72, we multiply it by 8. So we multiply the top by 8. 4 times 8 is 32. Now we're ready to add. When we add fractions, we keep the denominator the same, so the denominator remains 72. And we add the numerators. 63 plus 32 is 95. So we get x equals 95 over 72. That is our answer, but we always want to simplify our answer as much as possible. And we want to see if a number goes into both 95 and 72. It may be easier to change it to a mixed number first and then simplify it if possible. So I'm going to change that into a mixed number. 72 goes into 95 once. So x equals 1 whole, and then 23 are left over. So it's 23 left over the 72. So that helps me because I know 23 is a prime number, which means that unless 23 goes into 72, this does not simplify. 23 does not go into 72, so this is my answer, 1 and 23 over 72. Alright, I will make another example where you don't have to work with fractions, but I want you to try this one on your own, compare it with a friend, and then check with a teacher to make sure you're right. So this one, we're going to have x plus 8.5 is equal to 12.6. Solve that problem on your own, check with a partner, and then make sure it's right with one of your teachers. Pause the video until that's done, and then you can move on to the next property. The multiplication property of equality says that if you multiply one side of an equation by a number, then you have to multiply the other side by that same number in order for it to remain an equation. So this is what it looks like. If A equals B, then A times C equals B times C. Here's an example where we would use this. X divided by 5 equals 10. So I want to isolate the x, which means get it by itself. In order to get it by itself, and I have x over or divided by 5, I need to do the inverse operation of division, which is multiplication. So I want to multiply both sides by 5. So I have x divided by 5 here. I'm going to multiply by 5. If I do it to one side, I have to do it to the other. So I have 10 times 5 on this side. I have my equal sign, so I'm going to draw my line. Now here, dividing by 5, then multiplying by 5, results in 1. So we have 1 times x. So we have 1x left, which is simply x. And over on the other side, we have 10 times 5, so that is 50. So my solution is x equals 50. Now it's your turn to try one. So let's do x divided by 3 equals 15. Solve that, check with a partner, and then check with your teacher. Pause the video to do that, and then resume it when you're ready to go on. The last property of equality that we're talking about in this video is the division property of equality. which says if you divide one side of an equation by something, you have to divide the other side by that same thing in order for it to remain an equation. This is what it looks like. If A equals B, then A divided by C equals B divided by C. Here's an example where we would use this property. If we have 7x equals 126, I want to get the x by itself, and since 7x means 7 times x, I have to use the inverse operation of multiplication, which is division. So I'm going to divide both sides by 7. Divide by 7 on both sides. Now 7 divided by 7 is 1. So here we have 1 times x, so that's simply x. So we have x left on this side, and then we have to work on 126 divided by 7. So I'm going to do the math down here so you can see it. 126 goes in the box, 7 goes outside, 7 goes into 12 once, multiply by 7 and then subtract. 12 minus 7 is 5. Drop down the 6. So now we have 56. And 7 goes into 56 8 times. That's 56. Subtract, we get 0. So my answer is 18. And that's it. I have one for you to do on your own. Check your answer with a friend, and then check it with a teacher. This example is going to be 12x equals 60. Do that on your own, check with your friend, check with a teacher, and then move on. So the key concept in this lesson is to use inverse operations to isolate the variable. So inverse operations means what we consider opposite operations. If we have addition, then we would choose subtraction. If we have multiplication, then we would choose division. Those are inverse operations. And the word isolate means to get alone. The variable is usually our x, but we can use any letter we want to. So we want to get the letter, the variable, by itself by using inverse operations.